Hi, I'm Jay from the University of Washington, and today I'll be presenting our work on GazePointAR, a context-aware multimodal voice assistant for head-worn AR devices that leverages eye gaze and pointing gestures to resolve ambiguous queries. Humans naturally employ various pronouns, such as this and that, as they speak. For example, a person may enter a store, as in this example, and ask a clerk, "How much is this?" To resolve ambiguity stemming from pronoun use, for example this, humans use various nonverbal cues, notably speaking, eye gaze, and pointing gestures, to communicate their reference. For example, in this case, pineapples. However, state-of-the-art voice assistants like Amazon Alexa, Apple Siri, and Google Voice Assistant do not yet fully incorporate users' contextual information, meaning they do not support natural dialogue consisting of pronouns. To address this, we designed and built GazePointAR, a context-aware multimodal voice assistant for wearable AR that can disambiguate speech queries. Upon receiving a query with a pronoun, GazePointAR leverages gaze tracking, pointing gesture recognition, and computer vision to replace it with a description of the referent. In this example, a user is asking, "What is this?" while looking at a snack with foreign language written on it. The pronoun "this" is then replaced by a short phrase description of the snack. In this case, that would be packaged item with text that says Orion Poka Chip Original Sanggamja. Then we draw on advances in LLMs to then answer this modified query. To initiate GazePointAR, the user first says the trigger phrase, "Hey Glass," and the Microsoft HoloLens 2, our choice of AR headset, says, "Hi, I'm listening." This is to mimic how state-of-the-art voice assistants work, so for example, saying, "Hey Siri." Then the user can make a spoken query. If the user's query contains a pronoun, which in this case it does with "How much is this?", GazePointAR captures an image, runs various machine learning algorithms such as object recognition, optical character recognition, and celebrity detection. Then GazePointAR incorporates explicit gaze and pointing gesture data to determine a user's reference. So for example, the user is holding a bottle and looking at the bottle, which is going to be selected as the referent. This detected referent then replaces the pronoun in the user's query, so in this case, the word "this." And to do this, we generate a short phrase describing the referent, and this is in the form of object name with text that says, and then a list of 5 largest text in the object. So in this example, this could be bottle with text that says naked mighty mango 290 calories. This modified query is then sent to GPT-3 for processing, and the response is read aloud using a text-to-speech engine. And this takes about 7.5 seconds on average to complete. We now showcase a few example uses of GazePointAR. In this scenario, the user is asking GazePointAR to solve a math equation. "Hey Glass."
Hi, I'm listening.
"Can you solve this equation?"
The answer to 173 divided by 17 equals is 10.17647.
In this second scenario, the user asks GazePointAR about what the trash cans are for. "Hey Glass."
Hi, I'm listening.
"What goes into these trash bins?"
Landfill, non-recyclable items such as food waste, diapers, and single-use plastics. Recycling, paper.
And in this third and last scenario, the user is asking GazePointAR about a celebrity they ran into in a magazine. "Hey Glass."
Hi, I'm listening.
"Can you tell me more about her?"
Ursula von der Leyen, pronounced Ursula von der Leyen, is the President of the European Commission, the executive branch of the European Union.
With GazePointAR, we conducted a within subjects 3-part lab study with 12 participants to compare it against existing voice assistant products and better understand how users actually interact with GazePointAR. And this is possible because GazePointAR is a fully functional system. In part 1, participants compared GazePointAR to Google Assistant and Google Lens in a pasta recipe search task. In part 2, participants completed 3 additional context-dependent search tasks with just GazePointAR. And finally, in part 3, participants watched design probe videos, then brainstormed their own queries, and got a chance to try them out with GazePointAR. In part 1, the goal is to compare the 3 different voice assistant systems. They used Google Voice Assistant, Google Lens, and GazePointAR to find a recipe that uses a specific brand of pasta sauce. In part 2, participants completed 3 additional ambiguous query tasks with just GazePointAR, and participants were asking if a math equation is correct, comparing the price difference between 2 items, and finding more information about a celebrity. Finally, in part 3, participants first watched 5 design probe videos. These were asking if a cooking ingredient is healthy, asking for the answer to a math equation, asking about a snack with foreign language on it, asking what goes into different trash bins, and an accessibility example asking anything dangerous here. Then, participants came up with and tried their own ambiguous queries. In part 1, participants overall preferred Google Voice Assistant and GazePointAR over Google Lens. GazePointAR is simple, fast, natural, and human-like to interact with. Interestingly, participants formed shorter queries with GazePointAR than Google Voice Assistant, which participants actually really liked. In part 2, participants preferred speaking pronouns, especially if their references are difficult to pronounce or have long or unknown names, and this could be something like foreign language, etc. In the 3 tasks, participants mostly relied on Gaze to keep their interactions hands-free. Participants, however, identified several points of improvements for GazePointAR. First, it should support multiple pronouns. For example, they should be able to ask, which is healthier, this or that, which can be more natural than just asking, which is healthier between these. Second, GazePointAR should support queries with no pronoun, and this could be ambiguous, but not necessarily, it could be completely clear. An example of an ambiguous query with no pronoun is something like, what would be good for dinner, while at a grocery store. Third, GazePointAR should explain its answers and provide multiple options, similar to a Google search result. Fourth, it should use more robust ML models, as Google Cloud Vision's Object Localization API, although it's easy to use, kept labeling objects as packaged goods. And finally, users shouldn't have to dwell as much. Explicit input such as prolonged dwelling or lifting up an arm and keeping it up can be tiring. In part 3, participants came up with their own ambiguous queries to try. For example, which trash bin does this go into? What do they sell? And what's happening over there? GazePointAR answered these queries correctly. Participants asked a total of 32 queries. A majority of them were to derive information about an object or person. Some of these queries were unfortunately not answerable by GazePointAR. For example, asking about a building, a plant, an animal, or a car. This would require more robust ML models or perhaps even vision language models. In summary, GazePointAR is simple, natural, and companion-like to speak to. Informed by Study 1 findings, we then iterated on GazePointAR. We first replaced Google Cloud Vision's object localization model with YOLO V8 for more robust ML. We then utilized prompt engineering to send the user's original query to a LLM instead of modifying the query ourselves. And finally, we updated our LLM to GPT 3.5 Turbo, and this was before GPT-4. We first want to describe our prompt method very briefly. At the top, we insert the original user-spoken query. We then insert Gaze targets as a comma splice list. We still use the format of object name with text that says, followed by up to 5 largest text on the object. We do the same process for pointing data if users pointed at something. Otherwise, this is just left as none. We then insert everything else in the user's view that gaze or pointing did not capture, and this is to assist with plural pronouns like these and those. Finally, we ask GPT to output its answers as one sentence. With GazePointAR version 2, we conducted a 5-day first-person diary study. The first author used GazePointAR version 2 in various places and noted their observations. We now showcase a few interesting examples. In this scenario, the first author wants to find a similar but cheaper brand of clothes.
Hey Glass,
Hi, I'm listening.
it's a bit out of my price range. Can you recommend me a similar brand?
If Ermenegildo Zegna is out of your price range, you may consider looking at brands like Hugo Boss, Brooks Brothers.
And in this example, the first author asks GazePointAR for recommendations from a menu.
Hey Glass,
Hi, I'm listening.
can you recommend me something from here?
I would recommend trying the cappuccino from here.
And in this final example, the first author is looking for another book that's written by the same author, which just happens to be their favorite author.
Oh. Hey Glass,
Hi, I'm listening.
I really love this book. Can you recommend me another one that's written by the same author?
Based on the information provided, I would recommend the user to read Brave New World Revisited by Aldous Huxley, as it is another book written by the same author and is often considered a companion piece to Brave New World.
After using GazePointAR for 5 days, the first author agreed with the participants that it is natural and companion-like to interact with. However, GazePointAR still has several limitations. First, it does not store any gaze history, so asking about reference in the past or multiple reference is just not possible. Because GazePointAR requires explicit inputs like dwelling, users cannot shift their gaze or their pointing gesture. So, for example, it cannot answer questions like, hey, that was a really cool car, or hey, which is a healthier option, this or this. The first author also only used gaze because pointing is awkward to do in public. Finally, prolonged gaze leads to eye fatigue. The first author suggests future context-aware VAs should capture and store gaze data over time and use more robust CV models or even VLMs. In conclusion, while GazePointAR is simple, natural, and human-like to interact with, future context-aware VAs should leverage longitudinal human data and further study LLMs as an avenue for query disambiguation. Thanks for listening. Let's connect. And a special thanks to this amazing team for all their effort with this project.